In today's show, we're going to piggyback on some topics from our previous show. If you remember, we brought in a resident expert for Cisco networking, Tony Vargas, who teaches here at El Paso Community College, but he threw out a lot of words: TCP/IP, hexadecimal, binary, URL addresses. What does it all mean? So in today's show, I'm going to help clarify it. So don't worry, come on in and join me for another episode of Computer Train.
It's time for Computer Train, the weekly TV program that trains you how to use your computer, with your host, El Paso Community College faculty member Russ Myers.
All right, so we all need to take a deep breath because this show we're going to talk a little bit about some specific networking concepts. I'm not going to go too deep, and the number one reason for that is I'm a little shaky on networking concepts myself. That's not my particular area of forte, although I did take some Cisco training along with Tony at the same time. So let's review a little bit of what we talked about in the last show, and then I'm going to build on that and discuss some networking issues, hopefully define some of the words and some of the abbreviations and acronyms that Tony used in the previous episode. Okay, so the first thing we were talking about, by the way, this is a little bookmark that they created that we're going to hand out for students during registration time, kind of advertise our programs. Okay, so in the previous show, what we were talking about is our different programs that we have in the Information Technology Systems curriculum department. Okay, so we have computer programming, information tech in business, and then we have the networking. And as Tony described in the previous episode, we've kind of divided the networking into two areas. And one of the nice things about that I liked when we were doing this is the first year of the courses for both avenues are all the same. So the first year, no matter which one you're doing, you take all the same classes. And then as you're going into your second year, that's when you got to make a decision kind of about which way you want to go. Okay, so we have the networking option, and then we have the security option. The networking option is the one that he was describing where you're going to take more Cisco related classes. You're going to kind of keep going on that Cisco path, which I'll describe a little bit more in a minute. And then the other is the security option. So we have a wide variety of courses related specifically to security. That by no means, I want to say that Cisco doesn't talk about security, but we kind of specify it in that area. All right, one of the other things that I wanted to show here, which is a nice little bookmark we have, is here are the different areas of study. Once again, you can see we have networking operating systems. There's the item we talked about related to cybersecurity. Okay, here is information about places of employment. And essentially, when you're talking about these areas related to IT or specifically networking, the areas of employment are everywhere. Basically every government agency, community college, universities, businesses, they all have networking and computer related issues. So as opposed to when I first graduated with a computer degree, now the field is wide open. There's numerous positions in all sorts of different types of areas. Okay, and we just listed a couple of here. Computer programmer, that's kind of how I started when I graduated from UTEP. We have systems analysts, data support people, the people that fix the machines, the hardware, that upgrade the software. So you have software specialists, people that use desktop applications. So we've done some of those here in Computer Train, areas of Excel. I hope to do databases if I can talk myself into it. So all areas. We did put a salary range in here. That's kind of the salary range for someone who's going to be graduating with an associate's degree is you're going to get an entry-level position. In a second, I'm going to be talking about some specializations or certifications you can get in different areas. And businesses look for those certifications, which essentially means that you've gone through some fairly rigorous training, and then you've ultimately taken exams which tested you on that training. So we're going to take a look at some of those types of activities also. Okay, just for a moment, I want to deviate for a second talking about these degree plans and give you this file that this student brought to me that he created in Excel. He's actually a student in my advanced Excel class, and of course we've talking about some advanced issues about how to do calculations and things. So what he did was he created an Excel spreadsheet that lists all the courses in each degree plan of our 4 major degree plans. Because one of the things he noticed, which is very common across colleges, is a lot of the courses you take in actually are applicable in several different degree plans. So what he was trying to do is keep track of each degree plan, what he has taken in that degree plan and what he still needs to take. And so by the time he finishes his one particular degree plan, it will show them, okay, maybe I only need 3 or 4 classes that I could take in one semester, and I could get another associate's degree in another area of study. So I just want to take a second. I really liked it. I helped him. You know, he had some problems with the formulas, but I just wanted to take a moment to show you that. So here's what he did. He created a section for each of the degree plans that I was just talking about. So here's the networking one, here's the security networking, here's the computer programming, and then here's the business. And he went on the internet and he listed every single class that you have to take for that particular degree plan. Before the state of Texas came up with this 60-hour rule, which forced us to reduce our degree programs, the Information Technology Department picked 6 classes that we had in all degree plans. Once again, with the same thought about the networking degree. If you take one of those classes, it will apply across all. We still have a little bit about that, but the 60-hour rule that the state of Texas passed kind of disrupted that a little bit. Okay, so over here what he did was he listed the courses that he has taken. Then what it does is for each particular course, it looks it up and sees if it's in this table. If it's in this table, then this cell will say the word taken. If he has not taken that particular class in that degree plan, then it will say still needed. So by that, if you see, it gives him a picture of what he has taken in each degree plan and what he still needs. Okay, so for instance, the computer programming is kind of a unique degree where you have to take a lot of programming courses. So obviously that's the one where he's missing quite a bit. But some of the other degrees, especially the networking degrees, all the courses that he's taken there have applied across the degree plans. So I just thought it was a great idea of a student really, you know, one of the things students do is they kind of go in and out of classes, but they need to get more in tune with what they're doing there. And this student obviously has it in tune. Not only are they taking classes, but they are taking, you know, the big picture in mind and seeing what's out there for them. And so I really like that example. All right, so back to the topic we were talking about. Here is the networking courses. And one of the things that Tony talked about in that previous program was he utilized the terms CCNA and CCNP. So the C and the C stand for Cisco Certified. These are Cisco Certified classes. What that also means is that in order to teach those classes, the instructor has to be Cisco certified to teach those particular classes. So I went through the first level of Cisco courses, so I'm certified to teach that first level. But I can't teach these down here, the 4, 5, 6, 7, until I go and get my certification, which by the way, I'm not going to do. Okay? The N is networking, and then you're going to see in a second that Cisco has 5 levels of certification. So they have entry-level certifications just to get the ball rolling, get your foot in the door, but they have more advanced as you move along. And then these security courses, these are just community college courses, and those are for that networking security. I just want to show you briefly the Cisco website, which describes this a little bit better. Okay, so remember we talked about CCNA, CCNP. Okay, so Cisco has different levels of certification. So they have an E, so if there was an E at the end, then that would be entry level. Within each level, they have multiple certifications you could get. Okay, so we talked about CCNA, Cisco Certified Networking Associate level. So that's what we have classes for to train you for. So we have CCNA. Okay, then we also have a couple of CCNP. Notice once again, Cisco Certified, and then it's at the professional level. And then they also have Expert and Architect. And I have seen some of these exams, and like I said, I had to go through some of the exams at that first year level. They are very, very difficult. So it is something that is worthwhile if you take those courses to follow through and go through the testing and try to achieve those certifications, because businesses will look for that. You know, obviously there's going to be a lot of on-the-job training when you talk about the IT fields, but knowing that you have been experienced or exposed to that material and that you have tested and somewhat understand it will allow them to teach you what they need. Okay? All right, so if we looked at that, as I just described, we have 5 levels of certification: entry level, associate level, professional level, expert, and then architect. Okay, so the 2 here at the college, that's the CCNA, networking at the associate level. And then we also have CCNP courses, networking at the professional level. All right, so why do we do all this? What's important about this networking? So now I want to kind of get off of our curriculum a little bit, and then show you what we are teaching our students and why is networking so important within the industry. All right, in previous shows I have used this term, and a term I used was the Internet of Things. And what we are talking about there, as you see this progression, is originally it's a fixed device, which means in the early part of the internet you had to go to a desktop computer that was connected to the internet. Then as we moved along, we had more mobile devices. Okay, so the mobile devices, obviously the first one was your cell phone that could connect to the internet. Then from there we start to have other devices that can connect to the internet. So that's like your laptops, smaller tablets. Now where we're approaching is we have just about everything can be connected to the internet. So you have the Internet of Everything. And you can see as the years go by, we're at 2017 right now, we're approaching what they're predicting is 50 billion things connected to the internet. And remember, when you talk about being connected to the internet, you're talking about the transfer of information. Okay, so it's, people think that IT people, I just press a button and everything magically happens, but it's not. There's a lot of technology behind it to get us to do things. So now what are the things that connect to the internet? You've seen like security camera systems. You have your car. I can get a download in my Gmail where they've read my information for my car, when my oil needs to be changed, what's coming up, do my tires need to be rotated, are one of my tires lower inflated, because it's all connected by the computer now. So we have all sorts of things connected to the internet. And don't forget, when you have things connected to the internet, you're also talking about security issues. I read recently about a crime where they have Echo, which is one of the Amazon devices, where you can ask it a question. It's recording conversations, just normal day conversations. And don't forget, everything on the internet's being recorded. So whether you do it in a text message, in an email, whether it's spoken in those devices, your children are taking pictures, they're doing Instagram, all of that, don't forget, is being recorded on a computer somewhere, which I'm going to describe a little bit in a second. Okay, so I found a funny little cartoon here. They're at the maternity and they're checking on the baby, and the doctor is saying, your baby is developing very nicely, would you like to send it an email? Who knows what the future holds about all this internet connectivity business. All right, so here are a couple of terms that Tony talked, and I don't want to get too far into networking, but a little bit of knowledge about how things work would be nice. All right, so first of all, he talked about the term called LAN. LAN is short for local area network. Okay, so once again, when we use the term network, we're talking about things that are connected. So if you have your laptop or your car, if it's on the internet, it's connected. Okay, so essentially what you have in a LAN is you have all of your devices that you want to connect, no matter what they are. Usually you have a router, so if you have internet connectivity at home, you have a router somewhere, probably wireless now. Before that, they used to be hardwired, but now wireless. And then you have usually a server that takes track of all the services that these devices are going to need. Basically moves the information around. Then you take that where you have lots of LANs, so we have all of these examples of LANs, and we connect those networks. So we have essentially a network of networks. That's called a wide area network. And it's this type of topography that we're essentially talking about related to the internet. What I'm showing here is, remember, if you're talking about, this is one of the pictures I used to show when I taught networking about, you know, when we have all these cables all over the place, we want to make sure we do a good job with it, because everything that's connected, like my computer right now is connected to the internet, and it is not connected through wireless. There is a wire running into it. So that wire is going to what we call a wiring closet. That is a place where all the computers in this building, or probably in this part of the building, the wires all go to one central location to a router. Okay, so here is a good job of that being done. Everything is nice and neat, and you can see we're talking about hundreds of cables. Probably in this building alone, there's probably 1,000 computers dispersed in the entire administration building. Here's a job that I show that is not a good job. Okay, in order to work on that, that's a big mess. It's a big bowl of spaghetti. It's impossible to figure out where one wire goes to another. So not only do we teach the technology about the software and all that, but you're also teaching, you know, common sense type of skills about doing a neat job so when the next person comes along, they can follow it. All right, so the picture down here, this is an example of what we call a data farm. And all a data farm is a place where we have hundreds and hundreds of hard drive computers where we're storing all this information. One of the terms that I've used in a previous episode is called the cloud. When you say the cloud, what are we talking about? I asked that question a lot in my intro class. I said, has anyone heard the cloud? Have you done any type of cloud computing? And of course, they all don't know what I'm talking about, and they shake their head. And so then I ask them, does anybody have a Gmail account? Do you have a Yahoo account? Do you have Hotmail? Do you do Instagram? And of course, everybody does that. And I say that is cloud computing. All it means is you're running a service that's coming through the internet as opposed to running something on your local computer. So when you run Gmail, you're running software on Google's computers. So those computers are located in a data farm. Then don't forget, all the data you send, all the emails you send and receive are stored on a computer somewhere. Well, that computer somewhere is in a data farm. Okay, and it's just literally, if you look at all these rows of lights right here, every row of light is basically just another server. A server is just a computer. So it's just banks and banks and banks and banks of computers, like the one for Amazon. It's, you know, it's as big as a stadium. That's how many computers they need to track that, which I'm going to show you right now. All right, so all this information that's passing to our 50 billion devices connected, what are some examples to really get a picture of what I'm talking about here? It's really amazing. All right, so for instance, on a given day, Amazon processes about 4.5 with a capital B. That's 4.5 billion transactions. That doesn't mean orders. What I mean by transaction is, okay, you place an order. So that caused a transaction. They sent you a confirmation. That's a transaction. They forwarded information to UPS to deliver your product. That's a transaction. They had to send an order to the particular supplier that's going to provide that product. Not all the products at Amazon are at Amazon. You can get as a licensed Amazon provider. Okay? Then you have to make a payment. So you could use PayPal or you go through your credit card. So one order generates numerous transactions. So on any given day, we're talking about 4.5 billion per day. Okay? All of that information has to be stored, right? So 5 days from now, if you have a problem with your order, they can look it up. And they can tell when you ordered it, what did you order, what happened. They can track the UPS just like you can. Okay? So all of that is information that's traveling across the internet. It's simply amazing. All right, here's another one. There are 3.7 billion email users. That's not accounts. What we're basically talking about that is people. Okay, each person usually has more than one account. So usually a person might have, you know, on average 2 accounts. Like I have 2 accounts. I have my work account and I have my regular account. So I have 2 accounts. So 3.7 billion email users, which is 54% of the planet's total population. So you can see how this is expanding. The more they move the internet out into areas that didn't traditionally have it, the more of these transactions that are going to be on the internet are going to happen. Okay, and it's just going to be more and more information. All right, so those 3.7 billion users, send out approximately 250 billion emails per day. Of that 250 billion, 50% of it is what we call spam. We had described that in a previous episode just briefly. Spam is when a business sends out mass email. So you know when you sign up for something, you got to be careful of that, especially on the internet. They usually have a checkbox at the end. Send me, information about products, send me information about sales, all that. Make sure you uncheck them, or at least I uncheck them, because if you didn't and I had all of that, I would just get an email after email after email. And don't forget, if you do accidentally do that, usually on those emails at the bottom, there's an option to unsubscribe. So here's one about text where your children, of course, are sending, 500 a day. And I even talked to my daughter about that, getting her to realize, okay, this is how much you sent in a total day. Here's how much you're sending per hour. And I even went down to like every 5 minutes, this is what you're sending, because people don't realize. Okay, U.S. has about 260 billion texters. Okay, so that's somebody with a device that can send text, sending out about 9 billion texts every single day. Every single day we have 9 billion texts. And that's just the U.S. alone. Okay, so that stat I didn't even talk about worldwide. All right, so the idea I want you to get related to networking is all those texts, all those emails, all those transactions, everything, the videos, the television that's connected, that all takes networking to get it from one location to another. And so there's a lot of opportunity for jobs in that particular area. A couple other abbreviations he talked about briefly is where did the word internet come from? So it came from the prefix inter, which means between. So like if this was an economics class and we were talking about interstate commerce, we're talking about businesses between the states. Or in fact, our own street out here called I-10, Interstate 10. It's a road that goes all the way across the states. In fact, it goes from the west side to the east side of the United States. All right, so then the word net is from the word network, which I just described, like a LAN network, a WAN network. Okay, so now we have internet. It's essentially a connection of all those networks. So the internet in and of itself, the grand scheme of things, is just a giant web, which is where we get the other term from World Wide Web. If you remember the internet originally, web addresses always started with www. That stood for World Wide Web. In most cases now you don't have to put that in. It either defaults or the web address doesn't have that anymore. Okay? I read an interesting article about whether these words have to be capitalized if, for instance, you were doing a research paper in English at community college. Okay, my preference is I do capitalize it, but I've read some articles where it should be lowercase, so I guess it's personal preference. All right, how do you get internet at your house? Basically, you have an ISP, which stands for Internet Service Provider. So you get your service provider like AT&T, Time Warner, and they changed their name now, what are they called, Spectrum now. So those big guys sell their internet service to Tier 2, smaller guys, and then Tier 2 sell them to local ISPs. And that's where you get your internet service, from a local ISP provider. And it may be the same as the big company. All right, so let's talk about network communication. When two devices communicate, we need a language. In computers, that language is called a protocol. All right, so the language of the devices, we got to determine how they're going to talk to each other. That's called a protocol. Okay, so the most common protocol is called TCP/IP. Okay, Transmission Control Protocol, basically the language, and then the Internet Protocol, the language of the Internet. All right, so I talked about this a couple of shows ago about watching out for viruses inside an email, and one of the things I said was you can hover over the link, and if it comes up with the actual IP in numbers instead of words, it was probably not a good email, and don't click on it. We talked about numbers like this. All web addresses are in numeric form. Okay, it's 32 bits, which I'm going to talk about in a second. And it's in binary. That's one of the words that Tony talked about. Binary basically is where you have zeros and ones that most people are familiar with. For instance, this address, 216.58.193.206, this is what it looks like to the computer in binary format. Basically, every value place can be a 0 or a 1. And then I'm going to show you on the next slide how we add up that information. Okay, so binary notation, okay, known as base 2. That means every value place can only be a 0 or 1, 2 different values. For comparison that I show in my networking class, people are familiar with our numbering system. Our numbering system is called base 10. Every particular numeric value place can be one of 10 characters, the numbers 0 through 9. Then each column has a value. You've got your tens, hundreds, thousands, 10,000. Hexadecimal is base 16. It actually uses the numbers 0 through 9 and then the letters A, B, C, D, E, F. Okay, it takes a little practice to know some of this. There's another system called octal. Octal, of course, is A like octopus. Okay, 8 characters per value. All right, so let's talk about that. Each number is taken 8 bits. Each bit can be a 0, 1, so each bit is the value place. Okay, so if we look at that, each position columns represents a doubling of the previous. So the increase, like base 10, is ones, tens, hundreds. That's not how it is in binary. Okay, so our system is ones, tens, hundreds. Example, if I have this, there's 1 1,000, 4 100s, 1 10, and 6 ones. So that would be 1,000 plus 400 plus 10 plus 6. We don't do that, we just read the word 1,416, but that's essentially what we're talking about. All right, so here's an example of binary. Each placeholder starts with the value 1, then doubles to a 2, 4, 8, 16, 32, 64, and 128. 8 columns are 8 bits. Then whichever one is on, you count that. Okay, so for instance, this one says 132, so it's 32. You have 1 8, so 32 plus 8, and then 1 2. So it's 32 plus 8 would be 40, plus 2 would be a 42. So this bit manipulation is the number 42. So that's how we get the maximum number that can be representative if you add all of them up, if they're all turned on and you had ones everywhere, is 255. Okay, the other thing that helps us connect to the internet is inside the computer there's a NIC card and there is a hexadecimal number on the MAC. There's a MAC address. And that's the way they can track the information down to a specific device. So you see those things like in forensic files or on the police shows. They can track the information to a specific device going through this hexadecimal number. Okay, here's an example of a NIC card. This is where we would plug our physical device in, our internet, and then you notice this number. If you want to zoom in a little bit, not only does it have the numbers 0 through 9, but in any particular column, it'll have an A, B, C, D, E, or F. That's hexadecimal. Okay, I want to discuss a little bit. The internet's been around since about 1969 when the government connected some mainframe computers, and then it started from that. I used to do dial-up back in the early 90s, and at that time it was so slow you could actually see the characters being painted on the screen. You guys are not familiar with that. You just click on it, boom, it's on the screen. That's how fast it is now. Okay, well, I hope you enjoyed today's show. We want to thank Tony again for all that information that he gave us, and I hope I cleared out a little bit of things for you. So now connect your devices and start computing, and don't forget to be safe. Check those episodes out on YouTube, and we'll see you on the next episode of Computer Train.